By midday, the summer heat in rural India reaches a point where daily life effectively halts. The high temperatures suppress appetites, leaving people to wait out the sun in any available shade, simply conserving energy. To manage this environmental strain, the community relies on Aam Ras. This juice is made from pressing raw, green mangoes, providing a cooling sensation and the necessary glucose to sustain the body when solid food is difficult to eat. However, a severe climate spike creates a paradox. The same heat that makes this drink necessary for survival also ruins the harvest. This year, the extreme temperatures caused the mango yield to drop to a fraction of its normal volume. When a community's primary method of cooling itself is destroyed by the weather it is meant to combat, a seasonal heat wave becomes a long-term survival crisis. Suraj, a returning science student, proposed a mechanical solution. By carbonating the juice, they could expand the volume of their limited mango supply, allowing a handful of fruit to be stretched across the entire village population. But entering the commercial soda market requires specialized industrial equipment. A standard carbonation machine costs approximately 4 lakhs, a price point that effectively bars rural communities from the technology. Urban manufacturing models are built for large-scale profit, which often leaves smaller, low-income regions without access to basic tools that could improve their local resilience. To endure the summer, the village needed a scientific intervention that didn't depend on the commercial market. They would have to find a way to build the hardware themselves. Creating soda is a straightforward chemical process. It requires the forced infusion of carbon dioxide molecules into a liquid. For this reaction, gas must enter a high-pressure environment, forcing CO2 to dissolve into water rather than bubbling away. Factory machines are complex, but the minimum requirements are minimal: a gas source, a sealed container, and a pressure regulator. The principles of carbonation are common knowledge in secondary school science, even if the application is typically restricted to expensive industrial settings. Suraj worked with Pushpa, an engineering student, to apply the mindset of Jugaad, frugal engineering that uses limited local resources to solve complex problems. They bypassed the commercial supply chain by assembling the machine from scratch, using scrap metal for the frame and standard plumbing pipes to direct the gas and water. Because they were dealing with pressurized gas, safety was the priority. They installed a manual pressure gauge to monitor the flow and ensure the container didn't exceed structural limits. Their initial test illustrated the precision required. They opened the valve too quickly, and the sudden pressure surge exceeded capacity, causing the bottle to shatter. This failure led to a methodical recalibration. They adjusted the flow rates and tested different containers until they found the exact atmospheric pressure needed for safe, consistent carbonation. By applying this scientific method to salvaged materials, they demonstrated that factory-grade results are possible without an industrial budget. The final product, Aam Cola, combined local spices and a small amount of mango extract with the high-pressure soda they had synthesized in their workshop. This chart shows the dramatic increase in efficiency. Using carbonation as a multiplier allows the juice from a single mango to provide several servings, effectively stretching the ruined harvest to feed the entire village. When served to the villagers, the drink provided an immediate cooling sensation, offering several hours of relief from the physical strain of the summer heat. By focusing on the science of volume, the community managed to outmaneuver the crop failure and maintain their local defense against the extreme weather. Their finished machine cost a small fraction of the 4 lakh required for a commercial unit, proving that financial barriers do not have to dictate a community's survival. When STEM education is paired with the practical, frugal mindset of Jugaad, rural communities can bypass traditional markets and independently engineer solutions to their own environmental challenges.